This program is rated PG. It contains themes and scenes which may not be suitable for very young audiences. Parental guidance is advised.
Be advised that the views and opinions of the hosts and guests do not reflect those of the station.
Oh my God. Bistaro. Very baba. Wait, na yata bisa. Wait, yata keke ba.
नलाइकन आउने भयो हैन केही उपाय नै छैन यिको पनि नलाइकन हामीले देखेको बडी पनि
Good evening, ladies and gentlemen. Welcome to Philippines Uncut. I'm your host, Buddy Kunanan. Now, tonight's show is very timely because it comes on the heels of the very powerful earthquake that rocked Nepal just a few days ago. Now, tonight we remember our friends in Nepal and we offer special prayers for them as they slowly rebuild their lives and communities. And we also take time out to reflect on our own situation here in the Philippines and how we can prepare ourselves better in case, God forbid, a strong earthquake should hit us in this country. And joining us to talk about this very fascinating topic is the foremost expert and authority on earthquakes here in the Philippines, no less than Director Renato Solidum of the Philippine Institute of Volcanology and Seismology. Good evening, Director Solidum, and welcome to Philippines Uncut.
Good evening, buddy.
Yes, sir, and it's a pleasure to have you back here. And we've done a show before,
Sure.
But it's always good to have you here, sir, because I think that the public really needs a refresher every now and then on the need to better prepare our communities and society for the possible threat of earthquake. No. Now, sir, before we begin our topic, let's talk about you. Tell us a bit about your background and PHIVOLCS.
Okay, I am a geologist. I graduated from the University of the Philippines with a Bachelor of Science in Geology. I took up a Master's of Geological Sciences at the University of Illinois at Chicago, and my doctorate in Philosophy in Earth Sciences from the Scripps Institution of Oceanography of the University of California, San Diego. I've been working with PHIVOLCS since graduation from UP.
Wow. Okay.
Way back in 1984. And essentially, PHIVOLCS is the only mandated organization in the Philippines that deal with monitoring, with hazards and risk assessment, knowing which areas will be affected, the research, and also assisting in the awareness and preparedness of the public for hazards related to earthquake, volcanic eruption, tsunami, and other related phenomena like landslides. And essentially, PHIVOLCS started monitoring volcanoes way back in 1952, and the seismology function of PHIVOLCS was added in 1984. when the seismology function got transferred from PAGASA to FIVOC, adding the letter S
Yes,
to
yes.
FIVOC.
Yes, seismology, yes.
Yes, the seismology.
Okay. Now, sir, how big is the organization? How big is your agency?
Our agency is not so big. We're less than 240. And interestingly, if you compare our organization with other countries, for Indonesia, for example, our counterpart would be 4 agencies
Wow.
in Indonesia. In the US, will be 2. In Japan, it will be 1 organization and many universities. So we're kind of a unique organization that actually would do the 4 major aspects of an early warning system, which is espoused by the United Nations. And that is, 1 is monitoring and warning. Second would be the hazards and risk assessment. Of course, that would be communication of the warning. And the 4th would be the awareness and preparedness, which would deal with the proper response, timely response of people concerned once they receive the warning or the information. So we're like a complete package of delivering information that are needed by different sectors of society.
Yes. Which agencies do you most often work with? Which government offices?
Of course, we're under the Department of Science and Technology,
Okay.
but we work closely when it comes to disasters with the Office of Civil Defense.
Okay.
We're part of the technical working group of the National Disaster Risk Reduction Management Council. But commonly, we have activities that are multi-agency. We work with PAGASA, we work with the Mines and Geoscience Bureau, and we work with NAMRIA. Of course, within DOST, our information campaign is supported by the Science and Technology Information Institute.
Okay. Where are you located, sir?
We're located at the UP Diliman campus along CP Garcia.
Okay. And what kind of facilities do you have on site? What kind of special equipment do you have to monitor all these things that we've been
Well,
discussing?
in our main office, we have earthquake data receiving center together with the volcano data receiving offices. But obviously, the sensors are placed all over the Philippines. Right now, we have a 75-station seismic network, all digital. More than half or 2/3 would be via satellite in communication. But by next year, every station will be via satellite. This monitoring network, combined with actual raw data of different seismic stations all over the world, would enable our organization to monitor earthquakes all over the world, and obviously earthquakes in the Philippines. We have established sea level stations also to monitor possible tsunami. And by next year, with the current 10 that we own, we will add 19 sea level gauges via satellite also. So in the receiving center, you would see screens that would give you an idea of where the earthquakes are or whether the sea level all over the country has been affected by recently occurred earthquake.
Yes.
No? For volcanoes, we monitor 8 volcanoes. And 4 of these volcanoes, Mayon, Bulusan, Taal, and Canlaon volcano would have an multi-parameter integrated network where we can actually monitor these volcanoes
Yes.
in Manila, plus Pinatubo and Hibok-Hibok. But these 4 volcanoes would have instruments detecting earthquake, whether the ground is moving, cameras,
Yes.
and essentially we can monitor the volcanoes anywhere we are as long as there's internet connection, whether we're in the office or we're outside of the office or abroad.
All real time.
All real time. That would enable more volcanologists looking at the volcano and its data compared before where we rely on telephone or radio information sent to us
Amazing.
by volcanologists on
On
site.
site.
Yeah.
Amazing. Technology solutions.
And this
there.
would also enable us to share critical information to our partner researchers abroad.
Yes. Are there many volcanologists in the Philippines? I mean, are there many students taking up this fascinating field?
Not many. But we have enough people to monitor the volcanoes, but definitely we'll add more people who would be interested not only on volcanoes, but earthquakes and tsunami.
Yes.
Definitely, as years go by, our instrumentation gets more sophisticated. So we have different experts aside from geologists. We have physicists, mathematicians, chemists, engineers, civil, mechanical, electronics and communication engineering, electrical engineering. In terms of our awareness and preparedness group, we have geologists, teachers,
Yes,
community workers. So
It does seem that you have a lot on your plate given your
Yes.
240 person complement,
Yes.
manpower complement.
that's why if you have noticed, many of the things that I've mentioned about our monitoring would be focused on high-end instrumentation.
Yes, yes, technology solutions
technology.
really. Now, sir, we saw our video before we came on air about of the devastation really of what happened in Nepal. What are your observations regarding this catastrophe that hit
Well,
the country?
the earthquake in Nepal and particularly Kathmandu Valley is expected because Nepal is a country produced by earthquakes themselves. Before, the Indian subcontinent and Asia were separated by a big body of ocean called Tethys Sea. And India was being pushed towards Asia by plate motions or the blocks of rocks moving to either away or towards each other.
Yes.
And eventually India collided with Asia, and as the collision progressed, it formed mountain ranges.
Mount Everest.
Mount Everest, which is part of the Himalayas mountain
Yes,
range.
yes.
So the collision formed the Himalayas mountain range, and that collision is still ongoing. And where Nepal is and parts of India, Bangladesh, down even west to Afghanistan and Iran would be the collision. Even China is affected by it.
So it really was a hot spot. It really is a hot spot.
Yeah, it's known.
For seismology.
It's known. It's
Okay.
known, and so therefore, people would really need to be prepared for an earthquake. And the situation of Nepal is very similar to the Philippines, in a slightly different manner.
Okay.
But essentially, our country is being collided from both sides by blocks of rocks from the Philippine Sea to the West Philippine Sea and the Indonesian archipelago from the south.
Yes, yes. So it's
So we're similar to Nepal in terms of a collisional setting.
yes. Now, when you said it was expected, what do you mean by that, sir? When you say
Expected
Yes.
that there will be a strong earthquake.
Yes.
Of course, they don't know when exactly.
yes, 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 and then when you talk about the similarities with the Philippines, it means that the Philippines is also a hot spot for these types of
Yes.
seismic activity.
Yes. Although the added complication would be we're an archipelagic country. So an added problem, if there's an earthquake, which would traditionally generate multi-hazards, if there's a fault on land, and if it ruptures the surface, the first hazard will be the ground or fault rupture.
Yes.
But the major hazard is the ground shaking because the movement of blocks of rocks will cause vibration. That ground shaking can cause collapse of buildings. That can cause soft ground to liquefy, behaving like a quicksand. Steep slopes to have landslides.
Yes.
And even fire can happen during major shaking.
Yes, sir.
But because of the bodies of water surrounding us, then a large earthquake generated offshore under the sea can generate a tsunami.
Yes, sir.
So aside from major earthquake shaking, which we had around 90 destructive earthquakes in the past 400 years, some of these occurred offshore, and these had generated 40 tsunami events in the past
Okay.
400 years.
Sir, we have to pause for a break, but before we pause, before we pause for this break, we're going to show a short video to enlighten our viewers about how earthquakes happen, what goes on under the ground that leads to an earthquake. So let's have a video. And cue video.
Earthquakes are currently the world's deadliest and most damaging natural disasters. Between 2004 and 2011, nearly 700,000 people lost their lives when quakes hit countries as far apart as Haiti and Japan to Indonesia and Pakistan. Caused by movement of the Earth's tectonic plates, some regions are at constant risk. Seismic activity is concentrated along fault lines, areas of fracture in the Earth's crust, generally near ridges or tectonic plate boundaries. These huge plates are constantly in motion, and when they collide, one is pushed slowly beneath the other. The resulting friction creates energy along the fault lines, which eventually becomes so unstable they rupture, sending out a shockwave. This energy release is felt as an earthquake. After the initial jolt, aftershocks can be felt as neighbouring plates readjust into place. Most underground movement goes unnoticed by human beings but occasionally a big tremor strikes. Among the world's most active seismic zones, Asia, Turkey and Afghanistan, Northern Africa and the Americas. Earthquakes are measured by their magnitude and intensity. The Richter scale, the most famous indicator, rates magnitude, in other words, the energy released during an earthquake. In theory, there's no limit to the scale, but in reality, no earthquake has measured more than the 9.5 recorded in Chile in 1960. Meanwhile, the European macroseismic scale rates intensity, in other words, possible consequences. There are 12 different levels. 1 indicates the earthquake cannot be felt, while 12 indicates a total change in landscape. In the latter case, the scale acts as a warning against other natural phenomena, such as landslides, avalanches or tsunamis, which could be triggered. Each year, some 100,000 earthquakes are recorded across the world.